The following is the video solution from JSDT Solutions. Question 7 says, in the diagram below, TQR represents 3 points in a horizontal plane on a sports field. Okay, so this is the ground. And then they say that PQ represents a vertical flagpole. The angle of elevation of the top of the pole from R is theta. And angle T is equal to theta, TQ is equal to TR, and they're both equal to Y, and QR is equal to X units. And lastly, we are given that TQR is alpha, and we need to express theta in terms of alpha and then show that sine theta is equal to sine 2 alpha. Okay, so the main goal is you need to express theta in terms of alpha. Because they're asking for specifically angles, let's actually just look at those angles. We have theta here, but then there's no alpha in this triangle, in this right angle triangle. We only can relate it using trig ratios, and they specifically want angles. So let's actually just focus on the angles. Let's look at this triangle over here. In this triangle, we have theta. We also have alpha, but remember it's an isosceles triangle. So we can express theta in terms of alpha here. So this is opposite y, meaning this one, because it's also y, this angle over here in this triangle on the ground is going to be alpha. Okay, so just remember that this is now alpha. So let's just say that as well. Let's state it. So we can see that this angle TRQ is equal to alpha. Now we have to express theta in terms of alpha. So you see how they are inside a triangle, so they would add up to 180 degrees. So we can say that, we can see that in this triangle, you don't really need to say these things, but I'm just going to keep this in mind. In triangle TQR, we can take theta plus alpha, and they give us 180 degrees. And we just need to express theta in terms of alpha. So make theta the subject. So theta is equal to, so say theta, these together give us 2 alpha. So this is 180 degrees minus 2 alpha. Okay. So if this is 180 degrees minus 2 alpha, we've expressed theta in terms of alpha like that. But now they want us to also show them that sine theta equals sine 2 alpha. Why does this feel a lot for 2 marks? Okay, it's probably because it's probably not that deep, really, because they're saying sine theta and 2 alpha. Well, we have theta here and we have alpha, and we know, yeah, you see with 180 degrees minus alpha, remember from your cos diagram, okay, in sine's quadrant, this is where we have 180 degrees minus theta, this reduction. Let me just call it x, okay, to avoid any confusion. So they just have sine theta and then sine 2 alpha. We know that this, if sine is applied to it, it can reduce to 2 alpha. So that's what they did, okay? So they said if theta is equal to 180 degrees minus 2 alpha, then sine of theta would also be equal to sine of 180 degrees minus 2 alpha. Okay, so now we can finally just simplify this. Okay, using the reduction, you see that this will simplify to alpha, Okay, so this is simply just sine theta is equal to sine 2 alpha. And there we go. So they asked for those 2 things, and that is our answer. Moving on to the next question. Question 7.2 says, hence prove that in triangle PQR, that PR is equal to this. Okay, so it includes y, cos alpha, and cos theta. Okay, so we have this triangle in triangle PQR. So I'm going to just deselect that. Let's select this triangle here. The whole point is they're just finding the length or an expression for PR. So PR is the hypotenuse. Oh, in this triangle, the only thing we can relate it to is this theta that we have. So, and we also have x. Okay, so we can say we have theta and then x is the adjacent side and then PR is the hypotenuse. So clearly we need to use cos here. Okay, so we're saying cos of theta equals x over PR. Okay, so cos theta equals x over PR. And then PR needs to be the subject. So let's already make it the subject. And so if you transpose it, if you multiply both hand sides by PR, you get PR cos theta equals x. And if you divide both hand sides by cos theta, you get PR equals x over cos theta. Okay, so this is PR as a subject. How did they get it to look like this? Okay, so the first thing we see is the denominator is fine. It's just that numerator. So 2y cos alpha, that was clearly what x was. So we need to just find out what x is. So let's look. How do we find x? Okay, we can find x using this diagram. Okay, the triangle below here. So in this triangle QTR or RQT, to find x, this shouldn't be a problem. We can use the sine rule. So we can say we're trying to find x, so we're going to use the angle opposite x. And then with these ones, we already know their angles. It's alpha and y. Okay, so we can say x over sine theta is equal to y over sine alpha. Okay, so with this, we're saying x over sine theta is equal to y over sine alpha. And that is in that triangle RQT. I'll just say in triangle RQT. Just in case, something does not work out, we can backtrack. Okay, and now I'm just going to make x the subject because I need to find out what exactly x is, somehow equal to this, clearly. And then substitute it there so that we can finally find what PR is equal to. Okay, make x the subject. Just multiply both hand sides by sine theta. Therefore, x is equal to y sine theta over sine alpha. And it doesn't look like it yet, but let's just substitute it in. So PR is equal to, and we have x as the numerator. This is this. So we're saying y sine theta over sine alpha, and we're dividing by cos theta, which is, cos theta. Okay, it's the same thing as saying over 1, and then you can tip and times. So you're going to swap the numerator and denominator. So this is cos theta, and the numerator is 1. And then you change this to a multiplication sign. So we have PR is equal to, when we multiply, we have y sine theta over sine alpha cos theta. Let's just compare. How does it look compared to this? Okay, let's just see what it doesn't include. It includes cos theta, right? It has y, and then this 2 is not there, and of course everything else. So I'm just going to separate them so I can just make sense of this. So I'll leave this as y over cos theta, because that seems fine. And then I'll separate this. So multiply by that numerator is sine theta, and the denominator is sine alpha. And I just want to understand why they had this, eventually equal this. Okay, now looking at sine theta and alpha, yeah, it has to do with this. You see how sine theta is equal to sine 2 alpha, okay? So we need to make sure that we still have a cos alpha. Okay, so this is what they did. In place of sine theta, because sine theta was equal to sine 2 alpha, they replaced it with that. So I'm just going to say, but we knew already that sine theta was equal to sine 2 alpha. And in place of sine theta, let's substitute. So PR is equal to y, and we have sine 2 alpha over, and we have cos here, and then I think I should have still left it as separate angles. Here's why. Because if I say y over cos theta, and I say multiply by, and this changes to sine 2 alpha over sine alpha, then we can use double angles to expand this. So we're saying PR is equal to y over cos theta multiply by, and then this becomes 2 sine alpha cos alpha all over sine alpha. And then you see how these cancel. And that's where the 2 came from. So finally, it means that PR is finally equal to, we're going to say y times 2 cos alpha. So that's 2y cos alpha all over, and the only denominator left is cos theta. And there we go. So that's how it's equal to this. And moving on to the next question. Question 7.3 says, if alpha equals 49 degrees, x equals 20 meters, y equals 15 meters, calculate the area of triangle TQR. Okay, so it's that triangle we just worked with, this triangle. But let's just take down what they've given us so we don't have to find any unnecessary things. So they gave us alpha, they gave us x and y. Okay, so find the area of this triangle. Okay, using alpha, x and y, okay, we can just look at it like this. Using alpha, it's going to be this angle over here, okay, in this triangle, and then x and y. We could just focus on that. So we would have to use the area rule because we don't have any perpendicular height here. So the area of this triangle would be a half multiplied by the adjacent side, the side adjacent this angle, the center angle that we have here. So that's y times x and then sine of that center angle, which is alpha. So that's how it looks. Okay. So we're just going to substitute. So it's a half multiplied by 15 multiplied by 20 and then sine 49 degrees. Okay, and let's find the area. And the area of this triangle, okay, is 113 points, and that's going to round up to 21. Okay, and what was the unit of measurement? They said units, okay, x unit. So we're going to say it's this and then units squared. And that is our answer. Okay, and that is it for question 7.